Hey everybody, I'm really excited you're joining me today. I'm going to teach you how to write programs on your calculator. It's going to be really cool. And we're going to be writing programs for the Pythagorean Theorem, the Quadratic Formula, and the Discriminant. And make sure to stay tuned for the end because I'm going to do a very special program at the end, a little bit of a surprise one. So just to start you off, I want to go over a few programming concepts. First of all, programming is a really powerful way to reinforce your understanding of math concepts. So if you can write the code, you're really understanding the actual formula or how to apply the formula. And once you have the programs in your calculator, you can use them again and again in the future to assist you with these tasks. But just a word of warning, if you do reset your memory, the calculator programs are going to go away and you would have to completely retype them in again. Now, retyping them isn't the worst thing that could happen, but it is a little tedious, so you want to be very mindful of that. So let's talk about some key programming concepts. The first term I have here is the term control structure. And that means, how does my program flow? All computer programs depend on 3 control structures to make them work: sequences, branches, and loops. When you have a sequence, that means that when you run the program, each statement is executed in sequence. This means that each statement is executed in the order that it appears in the program, top to bottom. Okay? The branch, that's when the computer will take one of 2 or more possible routes depending on the truth value of the condition. Typically, it's going to occur in an if-then statement, and I have an example here. A loop is when the computer repeats a certain section of statements over and over, and a loop is also called an iteration. And I have an example here of drawing a square, and since you have 4 sides in a square, you would want to repeat this little block of code here where you draw the 4 sides. So just a really simple example. And then the last term we have here is a software bug. That's when you have an error or a flaw or a fault in the computer program, and it causes it to produce an incorrect or unexpected result, or to behave in unintended ways. Some tips: the programs are saved as they're written, and so that's why you have to name your program first. And you can simply quit by going to the home screen at any time. You can go back and edit any program anytime using the program editor. Delete deletes the character of the current cursor position. And be really careful because clear deletes the entire line of code and there's no undo, so be careful. Know the statements and the syntax in the programming language you're using. One little tiny syntax error will cause your program to not work at all, so you have to be really mindful of that. You want to know the data structures and the operations that are available, all the different commands that you could possibly use. And you want to know the design for the algorithm you plan to use. So what are the order of the steps that you want to use? And do you want to use if-then? Do you want loops? What do you need in your program to make it work really effectively and efficiently? So the first program we're going to write is on the Pythagorean Theorem, and I'm sure you're all very familiar, but I'm just going to go over it very briefly. It's a fundamental theorem in Euclidean geometry, and it relates the 3 sides of a right triangle. So across from the right angle is the hypotenuse, and the other 2 sides are called the legs. And the Pythagorean theorem says that the legs, if we call them a and b, a squared plus b squared is equal to c squared. So in order to get the hypotenuse, we would take the square root of a squared plus b squared. So we're going to write a program that asks for the values of a and b, which are legs of the right triangle, and it's going to compute and display the length of the hypotenuse. So that's going to be our first program. So let's get right into it. All right, so we're going to write our first program on the calculator, and as I press the buttons, you'll see them highlighted in red, and you'll also see them show up in the key press history. So we're going to press the program button, and we're going to create a new program. So we're going to go over to new, and we're going to select enter. And now we're going to name our program, and the first one we're doing is the Pythagorean Theorem, so I'm going to call that Pythag. And once we've typed in our name, we're going to hit enter. Now at this point, we want to prompt for our two legs, the sides of our legs. So I'm going to do prompt A and prompt B. So I'm going to go press the program button, and we're going to go over to the input output tab, and I'm going to select number 2 for prompt. And for the first one, I'm going to call that first input value letter A. So we're going to do alpha A. And we're going to hit enter. And we're going to ask for another prompt. So we go to program, input output, number 2. This time I'm going to call the prompt B. So I'll do alpha B. All right, so we have our prompt set up. Now what we want to do is type out the Pythagorean theorem, and we're going to store it into letter C. Alpha A plus alpha B close parenthesis, and we're going to store it. We're going to use the store button highlighted in red into variable C. That's alpha program to get to C. And we're going to hit enter. And we want to display what the output value of C is. So we're going to go to program, input output, number 3 for display. So I want to do quotes. So I'm going to do alpha quote, alpha C, and then I'm going to do a space. To get a space, I have to do alpha 0 and close quotes. I'm going to put in a comma, and we're going to type C, so alpha program. All right, this guy's all ready to go. So we're going to exit out of here, and we're going to run the program. So we're going to go to program, execute, which would be, we're just going to hit enter here, hit enter. I'll say A is 3. I'll say B is 4. And I should get a value of 5. That's correct. So if I have a leg that's length 3 and a leg that's length 4 in a right triangle, my hypotenuse would be a value of length 5. All right, great. So we're on to the next program. Okay, now the next 2 programs that we're going to write, very exciting, the quadratic formula and the discriminant. So a quadratic equation that's written in standard form, ax squared plus bx plus c, can be solved using the quadratic formula. And the quadratic formula will give you complex solutions, real or imaginary. The discriminant of the quadratic equation is going to determine the types of solutions that you can expect. So we're going to write a program just for the discriminant as well. I think you're going to really like that. So if we have our equation in standard form, the discriminant is b squared minus 4ac. If the discriminant is less than 0, we have no real roots, and we have 2 imaginary roots, and that means we do not have any x-intercepts. In this example, you can see we do not cross the x-axis. If the discriminant is equal to 0, that means we have 1 real root, and that means that we're going to bounce the x-axis in one place. And if the discriminant is greater than 0, that means that we have 2 distinct real roots, and that means that we're going to cross the x-axis in 2 places. Now, since possible solutions of the quadratic formula include imaginary numbers, you have to be sure that your calculator is in complex number mode, a plus bi. So I'm going to go over those steps with you and demonstrate that in the calculator. But here they are printed out. You're going to go to the mode. You're going to scroll down to what we normally have highlighted here is real. We're going to highlight a plus bi, hit enter, and quit out of here. And then our calculator is in complex number mode. So if we get imaginary solutions when we do our quadratic formula, it'll show us what those are. All right, so very exciting. Let's go on to these 2 programs now. So we're going to go back to program. We're going to say new, hit enter, and we're going to name it, I'm just going to call it quad form. Once we type that, we'll hit enter. Now in the quadratic formula, when it's in standard form, ax squared plus bx plus c, we need to prompt for the values of a, b, and c. So we're going to go to Program, we're going to go to the I/O menu, and we're going to choose number 2. So we're going to prompt for the coefficient a, hit enter. We're going to do it again for b. And we're going to do it one last time. Go back to Program, go back to I/O, choose number 2 for letter C. All right, so now our program is prompting for the values of A, B, and C. Now we have to tell it what to do with those values. So we're going to type out the quadratic formula, and you're going to have to be really careful here that you use parentheses where you're supposed to. We're going to do the plus part. It's plus or minus in the quadratic formula. We'll store the plus part into variable D and the minus part into variable E. So let's go ahead and type that in. And notice I used a lot of parentheses to make sure it does the correct order of operations. And I'm going to store this into the variable D. So I'm going to use the store button and go to alpha D. All right, so that's the first part of the quadratic formula where we're using the addition, negative b plus. Now we're going to do negative b minus. So we're going to hit enter and we're going to type it all again, except for we're going to change the plus to a minus. And this time we're going to store into letter E. Okay, so we have the quadratic formula typed out. We're sending one root to letter D and another root to letter E. And now we just have to display those roots. So we're going to use the display option. We're going to go to Program, go to Input Output, and choose number 3 for display. Right, and you probably want to turn alpha on at this point. So we're going to do second alpha. Now it's going to stay in alpha mode. So I need a quote, and I'm going to say root equals. Now to do the equals part, it's a little tricky. You're going to have to go to second math, and it's the first button under test. Okay, then we're going to have to do alpha again for a space and alpha quote. And then we'll do a comma and we'll say we want to display letter D, the variable D. So we're going to do alpha D. And hit enter. Now we're going to display root E, the root that went into variable E. So we're going to go to Program, Input Output, choose number 3, turn alpha on and let it stay on by doing second alpha. We're going to do a quote, R, O, O, T. We want to do an equal sign, so we have to go to second math, choose number 1, alpha 0 for a space, alpha plus sign for a quote. We do the comma, And we're going to display root e this time. So we want alpha e, which is alpha, and it's the sign button. All right. So our quadratic formula program is written. We want to make sure that our calculator is in complex number mode in case our roots are imaginary numbers. So we want to go to mode, and we're going to scroll down. Right now it's in real mode. We're going to change it to a plus bi. We'll display real numbers and imaginary numbers, so it will display any complex number. I'm going to hit enter, and we'll quit out of here. So in the first case, I'm going to use the quadratic x squared plus 2x plus 1. That factors to x plus 1 times x plus 1. That means that I should be expecting to get one real root. So we're going to go ahead and run our program. We're going to run number 2. Hit enter. So we're going to put in 1 for A, 2 for B, and 1 for C. And we get that our root is -1. We have one real root at -1. In other words, there's a bounce on the x-axis at -1. So that's our first case. So we got one root, both the same value. Now we're going to try another one where we get two roots. So I'm going to use the quadratic x squared minus 1. So that means A is 1, B is 0, and C is -1. Right, and I get a value of a root of 1 and a value of a root at -1. And now the last case is where I would be expecting two imaginary roots. I'm going to use x squared plus 1 for that one. So that means A would be 1, B would be 0, and C would be +1. We get our imaginary numbers at I and -I. So this is a great program, really useful to have on your calculator. I hope you enjoyed writing this code. All right, so the next program we're going to be looking at is the program on the discriminant. So we're going to go to Program, go to New, and I'm just going to call this one DISCR. And we're going to hit enter. All right, so for this program, we are going to be looking for the values of A, B, and C when we have a parabola in standard form, ax squared plus bx plus c. We're looking to input the values of A, B, and C so we can see what the result is when we evaluate the discriminant. So we need to prompt for A, B, and C. We're going to go to Program, Input Output, choose 2, and A, and hit enter. Do it again for B. And for C. All right, so now we need to calculate the discriminant. That's the part under the radical in the quadratic formula. So that's b squared minus 4ac. And we're going to store that in the variable d. So we're going to use the store button and alpha d. And now we're going to hit enter. All right, so if the value of d, if the discriminant is less than 0, we have two imaginary roots. So we're going to do an if then else statement. So we're going to go to Program, choose number 1, and we want to evaluate if d is less than 0. Now to get the less than sign, we have to go to Second Math, and we're going to choose number 5. So if d is less than 0, then, so we're going to go to Program, choose number 2, hit Enter. We're going to display 2 imaginary roots. So we're going to do the DISP command. Program, IO, number 3. Now we want to put the calculator into alpha mode. So we're going to go to alpha quotes, and I'm going to take the number 2. And now I'm going to put it in permanent alpha mode by doing second alpha. I'm going to do a space, and I'm going to type imaginary roots. Okay, so if d is less than 0, then display 2 imaginary roots. Hit Enter. Now, else. So if d is not less than 0, we're going to put in an else command, number 3. This time, the if is going to be if d equals 0. So Program, choose if. We have to go to second math to get the equal sign. Hit Enter. All right, we'll need another then command. Okay, this time if d equals 0, I'm going to display 1 real root. So we're going to go to Program, Display. I'm going to put it in permanent alpha mode, second alpha. And hit Enter. All right, and then we're going to do else again. This time we're going to check if d is greater than 0. We have to go to second math to get the greater than. Hit Enter. And we're going to adjust if d is greater than 0, we're going to display 2 real roots. All right, so that's our program. So we're going to quit out of here. And we're going to try a couple of different parabolas. The first one should be 1 real root, x squared plus 2x plus 1. So the value of a is 1, the value of b is 2, and the value of c is 1. So let's run the program. One real root, that's what we're expecting. All right, let's try another one. Let's do x squared minus 1. In that case, we're going to be getting 2 real roots. So the value of a would be 1, the value of b would be 0, and the value of c would be negative 1. Run the program. We get 2 real roots. And the last parabola I'm going to show you would be for x squared plus 1, and we would be expecting 2 imaginary roots. So a would be 1, b would be 0, and c would be positive 1. We get two imaginary roots. So another very handy program to have. Hope you enjoyed coding that one. All right, so for the big finale, this last one is what's called the magic 8-ball. And back when I was growing up, there used to be something called the magic 8-ball, and you could ask it a yes or no question, and then you would shake it, and an answer would rise to the top of one of the sides. And it was really, really cool and very fun. So you would have your user ask a yes or no question, and then you would press enter, and the program would generate one of 20 responses. So it kind of works out like it feels like a little bit of a fortune teller. You may want to rename your calculator Zoltar or Zelda, just because it's going to have some magical powers after we put in this code. All right, so hopefully you're ready. It's a little tedious, a little time consuming, but it's going to be really worth it when we're done. All right, so we're going to go back to program, going to new, and we're going to call this the magic 8. Now it's in alpha mode. We're going to use the number 8, so we need to turn off alpha mode by hitting the alpha button and pressing the number 8. All right, so the first thing that we want to do is we want to display the question, and then we want to put in a pause, because when we put in a pause, it's going to make the user ask the question and then hit enter. So I'll show you what I mean. We're going to do the display command, and we're going to put it in alpha mode, and we're going to display ask a yes or no question. Always have to start with a quote. Okay, then we're going to hit enter. We're going to do display again. I'm going to say then press enter. Now we're going to insert right here, we're going to insert a pause, because we want the calculator to pause and wait for the user to press enter. So we're going to go to program, and we're going to choose number 8 for pause. Okay, and that's all it has to say. So pause, we'll hit enter, go to the next line. We're going to display a blank space just to keep things neat. You'll see what I mean when I run the program. Okay, we're going to hit enter. Now we're going to generate a random number from 1 to 20. So we're going to go to math, over to probability, and we're going to generate a random number from 1 to 20. And we'll do paste. Okay, so we want to replace that end parentheses there with the store button, and we're going to store this into the value of A and hit enter. Now we're going to have 20 if statements, and each one is going to display a different saying depending on what the number of A is. So for example, we're going to go to program, we're going to go to if. So if A is equal to 1, then we're going to say then, and we're going to display one of the possible answers you could get as a response. It is certain. So we're going to go to program, then we're going to end that command, and then and we're going to do another one, and we're going to do this for 20 sayings depending on what the value of A is. So the next one's going to be if A equals 2. And the next saying is going to be, it is decidedly so. Next value is if A equals 3. And this time the saying is without a doubt. This time the value is A equals 4. And the saying for A equals 4 is going to be yes, definitely. Next value is if A equals 5. And for A equals 5, we're going to use the saying, you may rely on it. And for A equals 6, the next saying is going to be, as I see it, yes. The next one is if A equals 7, response would be most likely. Okay, for A equals 9, the response will be yes. For A equals 10, the response is signs point to yes. For A equals 11, the response is reply hazy, try again. For A equals 12, the response is ask again later. All right, for A equals 13, the response is better not tell you now. For A equals 14, the response is cannot predict now. For A equals 15, the response is concentrate and try again. Okay, for A equals 16, the response is don't count on it. For A equals 17, the response is my reply is no. For A equals 18, the response is my sources say no. For A equals 19, the response is outlook not so good. And finally, the last response is very doubtful. All right, we should be all set here. That was a lot of work, but now it's going to be all worth it. So we're going to quit out of here and we're going to run the program. So we're going to do program and we're just going to pick number 2, magic 8. All right, and it says, ask a yes or no question, then press enter. Okay, here's my question. Am I the best teacher at Mendham High School? Outlook not so good. Okay, let me try another one. Is this summer going to be a great summer? Without a doubt, that's what I want to hear. So it's going to always randomly generate a number and you can have lots of fun with your friends. You don't have to put in all 20 responses. I mean, those are just options. You could even do, like 8 or 10 responses and it's still really fun. Just make sure you have a good mix of positive and negative responses. All right, hope you enjoyed it. Thanks for watching.